Hey everyone, welcome back. Today, we're exploring a groundbreaking advancement in AI. How researchers are teaching large language models to solve math problems with unprecedented accuracy and efficiency. Ever wondered how AI tackles complex equations or proofs? Let's break it down. Here's the challenge. While large language models, LLMs, excel at language, math requires a different kind of intelligence, logical reasoning, step-by-step problem-solving, and self-correction. That's where this new research shines. A team from Japan developed a two-stage training method that transforms how AI approaches math, combining rigorous practice with smart optimization. Stage 1, Extended Supervised Fine-Tuning, SFT. This is where the model gets intensive training. Researchers fed it 7,900 high-difficulty math problems, each with detailed, step-by-step solutions. But here's the twist, they didn't stop after a few rounds. They trained the model for 10 full epochs, a process akin to drilling until mastery. Why? Because repeated exposure helps the model identify patterns, avoid errors, and internalize problem-solving strategies. It's like studying for a test, by reviewing the same material until you've mastered it. Stage 2, Reinforcement Learning with GRPO. Once the model is accurate, it needs to be efficient. That's where GRPO, Group Relative Policy Optimization, comes in. Think of it as a coach refining the model's thinking process. GRPO introduces a reward system with 3 key components. 1. Format reward. Did the model follow the rules? For example, ending with a boxed answer. 2. Cosine similarity reward. How closely did its reasoning align with a perfect solution? 3. Length penalty. The longer the explanation, the more it was penalized. This system teaches the model to balance accuracy with brevity, cutting unnecessary steps while maintaining precision. It's like training a student to solve a problem quickly without sacrificing correctness. Why this matters? The team tested their approach on rigorous benchmarks like AIME, a real-world math competition, and Math 500. The results? A 14B parameter model achieved 86% accuracy on AIME and outperformed 96% of teams in the AI Mathematical Olympiad, AIMO. These aren't just numbers, they represent a leap in AI's ability to handle real-world math challenges. But the impact goes beyond competition. By making models both accurate and efficient, this research paves the way for practical applications. AI tutors that explain concepts concisely, engineering tools that solve complex problems rapidly, and more. Plus, the team open-sourced their code, datasets, and models, so you can explore it yourself. So what's the takeaway? This work shows that combining deep, iterative training with smart optimization unlocks AI's full potential. It's a testament to how persistence and innovation can turn complex challenges into breakthroughs. Thanks for watching. If you enjoyed this deep dive, hit that like button and subscribe for more insights into AI's cutting edge. Until next time, keep questioning, keep learning, and stay curious.